In this video, we're going over naming binary ionic compounds. A binary compound is just a compound that is made out of two components. In this case, it's going to be two different elements. If specifically we're talking about binary ionic compounds, then the components are a metal, and a non-metal. When it comes to naming, for the metal element, we can observe that we're going to use the name of the element. For the non-metal, we're going to use the stem of the name for the non-metal, and we're going to add to it the suffix IED. Let's look at an example. If we have the ionic compound NaCl, the metal atom is sodium, which is Na, and we're going to write the name of the element. In an NaCl, we can observe that chlorine turns into chloride because the stem of the name for chlorine is chlor, and we added IDE to that stem name for our nonmetal. In table 3.1, you have a summary for all the names for nonmetals. We can see that specifically the most important part of this graph is going to be the last column, which is the name of the nonmetal anions that are going to be forming in our ionic compounds. My recommendation will be that you memorize this list. If we are given a chemical formula for an ionic compound, let's actually practice as much as we can with the following problems. How to write the name given the chemical formula for a binary ionic compound. As you can see in the following box that has that red outline, I have mentioned the rules when it comes to naming. The metal element always comes first, and we're going to write the name of the element. Next, we are going to write the nonmetal stem followed by the suffix IED. Let's do some examples. On letter A, we have K2O. The name of the metal here is potassium. Oxygen, when it is an ion, is called oxide. In letter B, we have BeCl2. Our metal is beryllium. Our nonmetal is chlorine, and in the name for chlorine will be chloride. Next, we have AlBr3. Because of space, I'm just going to put the two words one on top of the other. The name of the metal is aluminum. The name of the nonmetal ion is bromide. I'm going to now do the examples on the first row, meaning G, H, and I. Next problem that I have is MgCl2. Name of the metal, magnesium. Name of the nonmetal ion, chloride. Next, I have K3P. This is potassium. The nonmetal name is phosphide. And lastly, I have Li2S. This is lithium. sulfide. It is important to note that when we are writing the name, given the chemical formula, capitalization of the metal name for the purposes of the exam is not required. What it is required is correct spelling. So make sure that you practice when it comes to this. To finalize the practice, when it comes to binary ionic compounds, in the following problem, we are given the names for ionic compounds, and we must write the chemical formula. In a previous video, we saw how if we have the ions, we can write the chemical formula. If we have the name of the elements, we can write the chemical formula. This example formally introduced us to the idea of, given the chemical name for an ionic compound, let's actually write its chemical formula. So you can refer to the 4 steps that we learned previously for writing chemical formula when doing these problems. I'm going to do all 4 examples, starting with letter A. In letter A, I have potassium phosphide. Potassium, its symbol is letter K. Since it lives in 1A, its charge is +1. Phosphide refers to the element phosphorus. And because phosphorus lives in 5A, its charge is -3. To write the chemical formula, as we learned previously, I'm going to take specifically the value of the charge and make it the subscript of the other ion. The value of the charge, I'm going to make it the subscript. So this means that at first, I'm going to write this as K3P1. And as it was illustrated in the previous video, when we have a subscript of 1, that is always omitted. So my final answer is K3P. Let's do letter B. We have magnesium oxide. Magnesium refers to the element Mg. It lives in 2A, so it has a charge of 2 plus. Oxide refers to oxygen. Since oxygen lives in 6A, its charge is always -2. I already mentioned in the previous video that when you have a cation charge, that when it adds to the anion charge and it equals 0, all we have to do is to write the symbols for the elements. So my final answer for magnesium oxide is MgO. You can also come up with that chemical formula by exchanging the ion charge, meaning this 2 is the subscript of the oxygen, this 2 is the subscript of the magnesium. So at first, you will write Mg2O2, and then you will apply rule 4, which means that you have to do the smallest whole number ratio. So if we divide 2 into 2, that gives us Mg1O1. And because subscript of 1 is always omitted, we erase the 1. And as you can see, it gives us the same result. The correct chemical formula for magnesium oxide is MgO. Let's do letter C. We have lithium nitride. Lithium is an element that lives in group 1A, so it always has a charge of +1. Nitride is an element that lives in 5A, and it always has a charge of -3. We take the value of the charge, we make it the subscript of the neighboring atom. And my final answer here is Li3N. Because remember that the value of 1 that originally you can place next to nitrogen is always omitted. Let's do the last example, which is barium fluoride. Barium, its symbol is Ba, because it lives in 2A, is going to have a charge of +2 or 2 plus. Then we have fluoride, which is symbol F, and because it lives in 7A, in terms of its group, it has a charge of -1. We take the value of 2, make it the subscript of the fluorine. We take the value of 1, make it the subscript of the barium. So at first we have Ba1F2. Since the subscript of 1 is omitted, we erase it. So the final answer is BaF2.